So the first part of chapter 6 focused on parallelograms when we're talking about quadrilaterals, but we're adding in two quadrilaterals that are not parallelograms here, and that's trapezoids and kites. Skipping past that first section a little bit because we're going to prove those a little bit later. But getting on to the definition of a trapezoid, that's going to be a quadrilateral with exactly one pair of parallel sides. So again, not a parallelogram because I don't have two pairs of parallel sides. The parallel sides of a trapezoid are what we call the bases. So in this figure I have a base on the bottom and a base on the top. Those two sides are parallel. The non-parallel sides are what we call the legs. So again, I have the legs running from one base to another, but these are not parallel if I have a trapezoid. Trapezoid has two pairs of base angles. I have base angles along the bottom here, and I also have base angles I can refer to on the top because I have two bases in that trapezoid. Isosceles trapezoid is a trapezoid with legs that are congruent, so it's a special type of trapezoid. The angles of an isosceles trapezoid have some unique properties that we're going to see on that next page. So again, I have one pair of parallel sides. I still have my legs that are not parallel, but in this case, since it's an isosceles trapezoid, that's going to be congruent. You want to think it's the same kind of idea as if I had an isosceles triangle. It's kind of leaving out the top of that triangle. That bottom part would be an isosceles trapezoid. So those angles that we're going to look at, quadrilaterals and isosceles trapezoid, I know that each pair of base angles are going to be congruent. So again, if I have a parallelogram, we know that opposite angles are congruent. Since this is not a parallelogram, instead of opposite angles being congruent, I know that T and P, those are two base angles, those are going to be congruent. And also R and A, those are going to be congruent as well. So T and P, congruent base angles. R and A, for the other base, those are also congruent. So using that property with my isosceles trapezoid in problem 1, we start just by knowing that C is 65. And right away we know that F will also be 65 since those base angles should be congruent. And the only thing I have to do is solve for D and E. If I take 180 and subtract from 65, I know that D should be 115, which means that E, the other congruent base angle, should also be 115. And the idea behind that, again, doesn't really matter that it was an isosceles trapezoid. So that next question is asking, would they still have been supplementary? So the reason why we subtracted from 180 to find angle D was because those are same side interior angles. Since DE and CF are parallel, doesn't matter if these are an isosceles trapezoid or any other type of trapezoid, you always see that these angles from one base to the other, those should be supplementary. So it just so happens if it's isosceles, the base angles are the same. But no matter what trapezoid you have, from one pair of base angles to the other, those should be supplementary. So problem 2 is looking at that a little bit differently. We have a ring of a paper fan that's split apart into 20 congruent isosceles trapezoids on the second ring. And that's going to form a circle if I put that all together. So we want to find the measures of the base angles, and that's labeled as X and Y. So first thing I did was notice that we're looking at the trapezoid in the second ring, but if I look to the middle of that, I'm basically looking at an isosceles triangle. So I took that triangle and rewrote it down here. Let's see how we got those pieces. First thing we can do is that angle that's labeled angle 1 in the figure. We can find out what that angle is because if I take 360 degrees from a circle, we're cutting that circle into 20 sections. So if I did 360 divided by 20, that tells me the angle at the top of that triangle is 18 degrees. So now that I know that that angle is 18, first thing I want to do is find X, because again, if I ignore this line for a second that Y is on, then if I look at the big triangle, remember that was isosceles, so if I take 180 and minus 18, I get 162. That means that between these two bottom angles, those are split up evenly to make 162 degrees. So if I add all those together, that should make 180 for the triangle. So first thing we have to do is take 162, divide it in half. That gives us 81. So since the triangle is isosceles, we know that those base angles will both be 81. That gives our answer for X. We still have to find Y though, so we have to remember that if I combine these angles together, so one of each pair of base angles, I have 81 degrees for the bottom base angle, which means if I subtract that from 180, that'll give me the other pair of base angles, so Y's end up being 99 after I do that subtraction. So moving on also to different rules that we can use in an isosceles trapezoid, so not talking about the angles. This time, if I have an isosceles trapezoid, we also know that diagonals will be congruent. So we saw that before the rectangles. The same rule also applies if I don't have a rectangle. AC and BD would end up being congruent here because I have an isosceles trapezoid. Those are my two diagonals. So those are going to end up being congruent just like if it was a rectangle. So just like triangles, trapezoids also have midsegments, and midsegment of a trapezoid is a segment that joins the midpoints of the two legs. So pretty similar to how we used it for a triangle, it's also going to have pretty familiar properties if we remember what the midsegment did in a triangle. And those two properties, first of all, is that the midsegment is parallel to the two bases. In a triangle, it was only parallel to one base because I didn't have that other base at the top. But this time I could say that since MN is a midsegment, it's connecting the midpoints of those two legs. First thing I'd say about that is that MN will be parallel to RA, the upper base, and MN will also be parallel to TP, the lower base. So I can say I have two parallel pairs there. And the second thing we can say about that, similar to what we said for our triangle, is the midsegment is half the length, not just of one base though, but of the sum of the two bases. So if I'm looking for the length of the midsegment, that's going to be half of the sum of the two bases added together. So if I add my two bases, divided that in half, that should find me the length of that midsegment. So a little bit harder than with a triangle. So we're going to use that to find X and QR in this next question. If I'm told that I have a trapezoid with a midsegment at QR, it was a little bit hard to read there on mine, but what that means is QR will be again half the sum of my two bases put together. So to make that equation, I say X plus 2, that's my midsegment. That should be half the sum of one base, 4x minus 10, plus the other base of 8. And all we got to do there is work through and isolate for x with algebra. So I combine like terms, I distribute the 1/2, and then I add 1, subtract x. We get that x is going to be 3. So that answers my first question. If I'm looking for QR, all I got to do is go back and plug that in. Since QR was x plus 2, and I know that x is 3, QR is going to end up being 5. So pretty similar to how we use those in a triangle. So we talked about trapezoids, so now we're adding in our rules for kites. A kite is a quadrilateral with two pairs of consecutive sides that are congruent, but also no opposite sides that are congruent. So this is again not a parallelogram. I have two pairs of parallel sides. One pair would be here, so consecutive sides, or sorry, not parallel, but are congruent. And my other pair of congruent sides are here. So those are consecutive, but not opposite that are congruent. So rule for a kite that we can fill in is that if I draw the diagonals, so from B to D and from A to C, starting with a kite, I know those diagonals are going to be perpendicular. So we saw that rule also with a rhombus, so I have perpendicular diagonals for a rhombus, but also we see that in kites. So we're going to use that rule to help us find some angles here in that problem 4. If I start with just the 52 labeled there, that should be enough to get the other 3 that I'm looking for. And first of all, angle 1, since that's the intersection of your two diagonals, and since I know those diagonals are perpendicular, I know that any angle in the middle there is going to be a right angle. So first of all, we can say that angle 1 is going to be 90. To find angle 2, I can just add 90 and 52. And since I have a triangle here, I can just subtract both of those from 180. That gets me at the leftover part of that triangle, angle 2. That's going to end up being 38. Because again, if I do 38 plus 52 plus 90, that should make 180 for that triangle. And if I'm looking for angle 3, since I basically have two triangles that are the same, 52 is going to be the same on one side as it is on the other. So angle 3 is also going to be 52. So we didn't really have that as a rule there, but we also know that bisecting this angle at the top of the kite and also at the bottom of the kite, that angle would end up being bisected as well. So using that to find angles, and we can also put this into a proof. So starting with that kite that we have up here, we're going to prove that the triangle on the left, DEF, is congruent to the triangle on the right, DGF. And there's multiple ways to do this, but this is the way that I picked to solve that. And steps 2 and 3, again, could be flipped in either order. They don't depend on each other, but we're using both of those to prove in step 4. So the first thing that I said was based on the fact that we have a kite, that tells us that we have consecutive sides that are congruent. So we know that DE and DG are the same length. We can use that as a congruency. We also know that EF and FG would be another congruency. So that's important because that gives me one pair and also two pairs of congruent sides to use for those triangles, which means if I want to add in one more piece, I could just say this side down the middle, DF, it's shared in both figures. So since DF is congruent to itself, remember we call that reflexive. That gives us a third side to use. So if I have 3 pairs of sides that are congruent in 2 different triangles, those triangles are congruent. Again, we just call that side, side, side. So make sure again that we have these notes complete. I'm not going to do that last part on the back. There's nothing really for me to add, but that's something good to look at as a study tool, kind of get all those pieces connected. So make sure you come in ready for some practice.